Alright, let's take a look at this example. We have a summing amplifier or a summer, and we notice we have two inputs, 1, 2, coming into node A, and this is again an inverting amplifier configuration, and we're told to calculate V0, output voltage here, as well as the output current here. So that's what we're trying to figure out here. So first thing we want to do is we want to go back to our summing voltage equation, and what that is given to us is V0 equals minus R feedback over R1 times V1 plus R feedback resistance, the feedback resistance over the second resistor, times V2. And then again, depending on the number of inputs, you can continue, but since we only have two inputs here, the 2 volts and the 1 volt, so our R1 will say is our 5K, and our R2 will say is our 2.5K, V1 will be 2 volts, and V2 will be 1 volt. Yeah, so since we have two inputs, okay, into the summer. That's the equation we're going to be using. So it's just a matter of plugging in the data that's given to us. So we can just say, well, V0 is going to equal minus our feedback resistance is, our feedback resistance here is going to be our 10 kilo ohms. My R1 is going to be 5 kilo ohms, V1 2 volts, my R2 I'm going to say is going to be my 2.5, and V2 is going to be my 1 volts. Alright, so let's plug this in. 10 over 5 times 2 plus 10 over 2.5 times 1. Work this out, we get minus 4 plus 4, which gives us minus 8 volts. So now we've solved for our output voltage, which is minus 8 volts. Okay. And then we look here, our current, I0, is just going to be the sum of this current going out and this current going out. Okay. So it's going to be the sum of, let me write this down here. Again, looking at this point here, we got current going in is equal to the two branches going out here, current going out and going out on the other side. So the current I0 or I0 is the sum of the currents going through the 10 kilo ohm resistor and the 2 kilo ohm resistor through 10 and 2 kilo ohm resistors. Okay. Both of these resistors are going to have a voltage of V0, so both resistors have voltage V0 equals minus 8 volts across them. And this is because since VA equals VB, which is 0, okay? So we can solve for I0. I0 equals V0 minus 0 over 10 kilo ohms plus V naught minus 0 over 2, and this is going to be minus 0.8 minus 4, which equals minus 4.8, and we're going to be in milliamperes here. So now we solve for I naught, and then we solve for V naught. And that's how you do a quick calculation using a summer with two inputs to figure out what the voltage is at the output and the current at the output.